Hello, everyone. Hope you can hear me okay. I'm trying to record this over people using some really loud, noisy equipment outside my house. So I'm hoping that we won't be interrupted by that. But I'm going to go ahead and try to record your video anyway, okay? So we're going to go ahead and take a look at your second assignment for this week, which is Module 6, Lesson 7. So in this lesson, we're going to be going more in depth at looking at what you can tell me about a scatter plot, not actually the making the scatter plot itself. So let's go ahead and get started. So in the beginning, we have a fill in the blank section, which is just you filling in and going over the different things we're going to be looking at in today's lesson. So I'm going to go ahead and pause the video and write down all the answers for that, and then we'll go through and talk about it. Okay, guys, let's go ahead and go through this together. So in the previous lesson, we looked at how scatterplots show trends in bivariate data. So remember, we were looking in lesson 6 at the car, different weights of cars, and their fuel mileage, and seeing if those had any kind of relationship with each other. So when we look at a scatterplot, we should be asking ourselves the following questions. Part A says, does it look like there is a relationship between the two variables used to make the scatter plot? Because remember, a scatter plot is a way to show if there are any trends or if there even is a relationship between two sets of data, like in lesson 6. Part B says, if there is a relationship, does it appear to be linear? So we're checking to see if there's like a line that you could potentially draw through them. That's something we'll look at a little bit. That's called a line of best fit, but that'll be a different day. And then part C says, if the relationship appears to be linear, is the relationship a positive linear relationship or a negative linear relationship? So think back to when we've been working with linear equations, and we were discussing how to tell the difference between a positive sloping line and a negative sloping line. A positive sloping line is going, as it goes from left to right, will start lower than it finishes. So this would be a positive sloping line or positive linear relationship if the points are following that type of pattern. For negative, we're looking for something that starts higher than it finishes. So it's going to be a decline. It's like you're going down the hill from left to right. So keep that in mind when we're answering some of these questions. And we'll go ahead and read through the second part here that you guys were filling the blanks in on. To answer the first question, look for patterns in the scatter plot. Does there appear to be a general pattern to the points in the scatter plot, or do the points look as if they are scattered at random? So if something is scattered at random, we would say that it does not have a linear pattern. We'll look at what that means here later on. If you see a pattern, you can answer the second question by thinking about whether the pattern would be well described as a line. So that's where we're looking for that linear relationship. Is everything trending in the same direction? And then when we answer the third question, we'll need to determine whether we think it's linear or negative. And as I mentioned before, remember, a positive linear relationship will look like a line with positive slope, and a negative linear relationship will look like a line with negative slope. Okay, I'm going to go ahead and take us down to our first question, exercise 1. All right, so here's the first scatter plot we're going to be analyzing and answering the questions about. So the first thing it asks us is the question, is there a relationship? So we're looking to see if we think that the points have any kind of pattern to them, or are they randomly scattered around? In this one, they don't appear to be randomly scattered around to me. I feel like it's trending this direction because everything's pretty clustered together and they're all going from higher to lower. So I would say yes, there is a relationship. Our second question says, if there is a relationship, does it appear to be linear? So since I feel like I can draw a line through them and they're all generally close to that line, I would say that yes, this is a linear relationship. Now, if my points were scattered all around in random spots, so let me add some pretend points in here. I'll use green for that. So if I had just random points everywhere and I couldn't draw a line through them at all, that is what it means by not having a linear relationship. So for there, it would not be linear. It also would not be linear if there's a curve to them, but that's a story for another day. All right, let's go ahead and take a look at our third question here. It says, if the relationship appears to be linear, is it a positive or negative linear relationship? So on this one, everything's trending down, like in a negative sloping direction. It's a decline from left to right. So I would say that this is negative. Okay, so this is a good example for you of having a negative sloping scatter plot, which we would say has negative correlation. All right, I'm going to go ahead and take us to our next one. All right, so here's Scatterplot 2. We're going to answer the same questions about it. It says, is there a relationship? It's the first thing we want to look at. Well, I feel like everything seems to be trending the same way, like on the last one. I feel like I could draw a pretty decent line that's close to all of the points. So I would say yes. There's some kind of pattern here. And then it says, if there is a relationship, does it appear to be linear? Well, if I feel like I can draw a line through it and everything's close together, then yes, I'm going to say this is linear. And then our last question, we want to determine whether we think if when it's linear, if it's negative or positive. Since all of the points on the far left are lower than all the points on the far right, I would say this is a positive relationship. Okay, and now let's look at the most interesting one. This is your third one. All right, so Scatterplot 3. Clear our screen a little bit here. The first thing it asks is there a relationship? So as I look here, on the previous ones, I drew a line to help me kind of determine where I thought the trend was going. But here, I have points that are scattered. This point's way off here. This point's way over here. And then, I don't know if you guys saw, but there's one all the way down at 0 too. So since these points are so scattered, I would say that there's not a relationship here. Because even if there was a relationship, I would call these ones that are farthest away from the rest, I would call them a word called outliers. Outliers are points that don't fit with the rest of the data. So maybe everything else follows a pattern, but just a few do not. But here, everything is very scattered. So I can't comfortably say that there is a relationship at all. So I'm going to go ahead and say that no, there is not a relationship. And since we don't think there's a pattern or relationship anyway, these last two questions don't actually apply. So I'm writing NA for not applicable. Okay, so these are a few examples of scatter plots for you guys and how we would look at them and analyze them. So next week, we're going to be starting on a project where you guys are going to actually make your own scatter plot, and you're going to have to find your own information to use for that. So you guys will receive the details on that coming up next Monday. My goal for you guys by the end of this week is just to get all of your assignments that you have so far done. So if you have any questions, please let me know. And you can contact me via email or in the comments as usual. All right, guys. Tomorrow, remember, tomorrow is our Zoom meeting if any of you want to join. All right. Have a good rest of your evening.